This is the Wiley Coyote problem for chapter 10 slides. So we're given that the Wiley Coyote weighs 20 kilograms. And we're told that he is shot straight up from a cannon with an initial velocity of 50 meters per second. So V initial is equal to 50 meters per second. And we want to find if his entire kinetic energy is transformed into potential energy, what is the maximum height he could reach? So we want to know what Y final is. And then the other thing we want to know is if 20% energy lost due to air friction, what is the maximum height? So this would be like YF. We'll call it friction, YFF. All right, so let's call this one A and this one B. All right, so I'm going to draw a picture first. So I'm going to say that there's a cannon on the ground, and it's going to shoot him right up. So he's standing inside here, and let's say the stuff under here is what's going to shoot him up. We'll put his head there. And this is my before. And he's going to be shot up with a velocity of 50 meters per second. And then this is my after. And let's say he gets to be here. And so this is going to be Y final. So this is at Y equals 0. Okay, so I'm going to say delta K plus my potential energy, change in my potential energy plus the change in my change in my kinetic energy plus the change in my potential energy is equal to the work. And I know there's no work for the first part because we assume that there's no friction. So I'm just going to set that equal to 0. And now I'm going to say, so delta K is K final minus K initial plus U final minus U initial equals 0. And this is going to be 1/2 mv final squared minus 1/2 mv initial squared plus mgy final minus mgy initial equals 0. And so thinking about this, when he reaches the top here, right here, he's going to have 0 final velocity, so that's going to go to 0. When he starts out, his y initial is going to be 0, so that's 0. So now I'm looking for y final. So I'm gonna write this out again. So mg y final is equal to, and I'm going to bring this over to the other side. So I'm adding 1/2 mv squared to this side and to the other side, and I get 1/2 mv squared initial. I'm going to cancel my m's, and now I'm going to solve for y final. So by dividing by g on both sides, so y final is equal to vi squared over 2, and then dividing by g gives me that. So if I plug in, I'm going to have 50 meters per second squared over 2 times 9.8 meters per second squared. And to calculate that, I'm going to have 50 times 50 divided by 2 times 9.8. And I get y final is equal to 127.6 meters. So that's my part A, and now for B. I'm just going to do this. So for part B, I'm going to do the same thing. So my delta K plus delta U is equal to W. And so my change is, the way I'm going to do this is instead I'm going to say the way I'm going to do this is I'm going to actually write this as change in kinetic energy plus the change in potential energy plus delta E thermal equals 0. So this is where I'm going to put the loss of 20% energy here. So I'm going to say, okay, I'm going to say my delta E thermal is equal to 0.2 of K initial. So my K initial is my starting kinetic energy. My total energy is my K initial, my 1/2 mv initial squared, and I'm losing part of that. So that means I'm going to write, come down here, and I'm going to say K final minus K initial plus U final minus U initial plus 0.2 K initial equals 0. And now I'm going to put these two together. So I'm going to say K final minus K initial plus 0.2 K initial plus U final minus U initial equals 0. So that means K final minus 0.8 K initial plus U final minus U initial equals 0. So 1/2 mv final squared plus 0.8 times 1/2 mv initial squared plus mg y final minus mg y initial equals 0. So I know my v final here, this is 0. I know my y initial is 0. And so now I'm looking for y final. I can cancel out my m's. And this should be a negative right here, negative. So now I'm looking for y final, so I'm going to add this part right here to both sides. And so I have g y final is equal to 0.8 times 1/2 is 0.4 vi squared. And dividing both sides by g, I get y final is equal to 0.4 times vi squared over g, which is 0.4 times 50 meters per second squared over 9.8 meters per second. So I've got 0.4 times 50 divided by 9.8. And that y final then gives me 102 meters. So when I lose that energy, due to air friction, my Wiley Coyote doesn't go as high, and so I can see that in my y final that is 102 instead of 127. My energy bar chart for this is going to be for part A. I start with all kinetic and no potential, and then I finish with no kinetic and all about the same height. They look about the same height, potential. And now for part B, I have the same thing for A, all kinetic and no potential. And for the final, I have no kinetic and I have some potential and some E thermal.